So we talked about sample surveys, we talked about observational studies, we talked about experiments. And so we talked about the differences and kind of how we carry those out. We talked about the different conclusions that can be drawn from those. Observational studies, we can generalize to a larger population. Causation is not a thing though. So there is no cause and effect from an observational study. Experiments, we're not as easily able to generalize to a larger population, but we are allowed to find cause and effect relationships. So there's kind of some advantages and disadvantages of each type. Now what we're going to be focusing on the next 3 days is when we want to collect our data, because that's what this entire unit's about. How do we collect our data correctly so that we're able to analyze it the way we want to analyze it? So how do I get the information that I'm going to need so that I'm accurately representing that population value? So we said when we identify our population of interest, we're probably not going to be able to access the entire population, so we need to take a sample. And we need to make sure that we're taking a sample that is representative of that population. We're going to be measuring something, calculating something, whatever the case may be. We want that value that we find to estimate the true population value. And that's not going to happen unless we put some things in place to make sure we're collecting our information correctly. So, as far as sampling types go, the first type we're going to mention, and we really only mention it to start with here, it's called the census. This is one that in the real world is not typically feasible because it requires you to sample your entire population of interest. So as we discussed yesterday when we talked about identifying our population and sample, in almost every real world scenario, the population that we're interested in is going to be too expansive for it to be efficient to try to collect information from all of them. So it's going to be either too time consuming, it might be too costly, whatever the case may be. So if I have a small enough, condensed enough population of interest, then I could perform a census, and I would want to do that. If I perform the census, I'm calculating that true parameter. That's what I'm always after, is what is the true parameter for this population of interest. So if I can get it, I want it. But, like we said, this isn't going to be a very feasible option in most instances when we're talking real-world scenarios. So I'm not going to be able to have access to my entire population. That's where the sampling comes in. So as far as sampling goes, there are 5 different types of good sampling. There's a couple types of bad sampling. That's what we're going to be covering over the next 3 days or so. And so the first type we're going to talk about, probably one of the most important, is the simple random sample, which you will most often see abbreviated as SRS. And it's important to make note of that abbreviation because that is almost always how you're going to see it when they refer to it in problems. It's important to know that SRS stands for the simple random sample. We're going to talk about what's called a stratified random sample tomorrow, which is also an SRS. But this one gets the abbreviation. Now, what you're going to notice is that every single type of good sampling we talk about over the next 3 or 4 days is going to employ some form of randomization. It's going to employ some form of this sampling right here, the simple random sample. So when we conduct a simple random sample, every individual from our population has an equal chance of being selected. But it goes even further than that. When I choose an SRS, it gives every possible sample of the desired size an equal chance of being chosen, and that's an important distinction. So as far as a simple random sample goes, it's literally taking the population, throwing it in a big, like putting names on the hat, right, and just drawing randomly. Everyone gets thrown in the pool. Everyone has an equal likely chance, or an equal chance of being selected from that pool. And so what that means then is if I were to select multiple times, so I select one random sample and get an estimate, then I select another random sample and another random sample and so on, okay, every time I select that random sample, any sample from that pool has an equal likelihood of being selected. Now when we select a simple random sample, what's going to happen is you're going to have a list of individuals, and what you're going to do is you are going to assign those individuals a number. So you're going to label every individual. When you label your individuals, you need to make sure that each individual has the same number of digits assigned to them. And you always want to try to use as few digits as possible. So what we mean by that, if I have a population I'm selecting from that has 8 individuals, okay, I can use the digits 1 through 8 to label those individuals. So I'm simply selecting one digit at a time. If I have 25 individuals that I'm selecting from, the largest label would be 25, which has 2 digits. That means when I start labeling at 1, I need 2 digits on that as well. So if I'm looking at 1 through 8, like that first example, right? Then I could have a label 1, 2, 3, all the way up to 8. But like we said, if we have 25 individuals that we're selecting from, that 25th individual has 2 digits as a label, I need to make sure all of my labels have 2 digits as well. So in that instance, instead of 1, 2, and 3, we'd have 0, 1, 0, 2, 0, 3, 0, 4. We got to have a 0 placeholder in the 10 spot because every label has to have the same number of digits. And that's going to make more sense when we start talking about that random table that you guys have there. Okay. If we have 400 people that we're selecting from, so 400 people, the largest value is going to be 400. So that means every one of my labels has to have 3 digits. So 001, 002, 003, and so on. Now, one thing to consider here, this goes into the using as few digits as possible. So you have to think about what's your largest unit or what's your largest label going to be. That dictates how many digits you're going to have. Now let's think about the case where we have 10 individuals. So if I have 10 individuals that I'm selecting from, right, if I start at 1, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my next one would be 10. Okay? Now if I go to 10, that means that I have to go back and I have to put an extra digit on every single one of my values. I've got to go 0, 1, 0, 2, 0, 3, 0, 4. What would be an alternative to that though? So when I go to start labeling, I get up to 9, I have one more person to label. If I go to 10, right, then I got to go back and make everything 2 digits. The more digits I add, the longer it's going to take me to find my sample. So that's why we're trying to use as few as possible. So we haven't used one of our single digits yet. So if I have 10 individuals, I can let that last individual be 0. And it allows me to stay with 1 digit per person, which is going to be much easier to search for and find the appropriate sample that I'm looking for. Okay? Same thing if we have 100 individuals. So if I'm selecting from 100 individuals, as I start to label, I'd have my 0, 1, 0, 2, 0, 3. I'd go up to my 98, 99, and then I have that one last individual to label. If I make it 100, then I got to go back and make 3 digits for everything. That's going to make it harder for me to find what I'm looking for. So instead, that last value can just be a double 0. We haven't used that combination yet. So as you're going through these and you're thinking about labels for your individuals, you want to try to think about, is there a way to minimize the number of digits I'm going to be using? So think about what that largest digit would be, or that largest number would be. How many digits does it have? Everything has to have that same number of digits. And then once we have everything labeled, we simply use our table of random digits, or we use our calculator. We'll talk about both processes today, to select the sample that I'm interested in. And we'll go through quite a few examples here so you see kind of what this looks like. But the first thing we're going to talk about then is that table of random digits. So look at that table of random digits. Go ahead and pull that out. If you look at the left-hand column, so that left-hand column tells you the line number that you would be starting at. So like when you see the left-hand list here, there's just the 3 digits, so line 101, 102, 103, things like that. That's how you're going to know where to start. Like, so some of the homework problems, when I want you to use this table, I'm going to tell you, using the table, start at this line specifically and start generating a random sample. Okay, so if you start on the front side is what we call it, line 101, so make sure you see that on there. You guys should be seeing the exact same random digits that I have up here, right? Okay, so what they've done is they've created this list of random digits. Now, creating random digits is an extremely complex process. So they have entire books devoted to this. They have different processes they use, and there are books with thousands of pages that have just random digits, because randomization is imperative. It's extremely important with these sampling processes, with simulations, when we get to probability in a couple of units. So randomness is an extremely important thing. And so basically what's going to happen here is, once we've labeled our individuals, we're going to be told, or we're going to pick. Sometimes you'll have the freedom to pick where you want to go. So you're going to pick a line to start at. Maybe it says like line 110. So we go to line 110. Now, depending on my labels, I know how many digits I need to be looking at a time. And that's why I have to have the same number of digits for everything. If I had labels like this, right? When I go to start to pick random numbers from my list here, I've got some with single digits, some with double digits. When I go to pick these numbers, I don't know which one I'm supposed to be picking at that time. Am I supposed to be going 1 digit at a time, 2 digits at a time? When do I switch back and forth, right? So there's no way to actually get that process going. So that's why when we label, everything has to have the same number of digits. So if I was going 0 to 8 or 1 to 18, it's 0, 1, 0, 2, 0, 3, 0, 4. So then when I start going through my list, 38 would be the first 2-digit number that I see. That's not part of my list, so I ignore it. Then I go to the next 2-digit number, which is 44, not in my list, so I ignore it. 84 would be my next list. And so I want to kind of point out some things on this list here. This is a continuous list of numbers. They have it broken up because if I just put a giant list of numbers on here all together, it's going to be really hard to keep track of where you're at in the table. So they've separated it out. Every 5 lines, they change the shading so you kind of can keep track a little bit there. And they group the digits in groups of 5. Now that's simply to separate some things out and allow you to better follow where you currently are. Keep track of where you're at so you don't lose your place. If you lose your place during this process and you're like 3 lines into this random digit table and you're trying to find your sample and you mess up and don't know where you're at, you got to start the whole thing over again. Okay? So when you're doing this, when you're looking at this table, It is one continuous list. So the first two digits 38, next two digits 44, my next two digits are 84. Those are together. They're spread out, again, because of the organization of the chart, but those are the next two digits that I'm selecting. So I'm not just going to pick or skip values that are at the end of each group of 5. They're part of that continuous list. Does everybody understand what I'm saying here? Okay. So I would continue that process. So 84 is gone, 87, 89. First one would be 18. So for my sample, that would be the first individual that I would select, because that's the first number that fell into the list that I'm looking for. Okay? So then I would continue on until I have selected as many people as I wanted from my list. So that's kind of our basic process. And like I said, we're going to go through some examples so you get some practice with this, but that's what that's going to look like. Also then, it kind of highlights the reason we want to make or try to have as few digits as possible. If I was going to 100 individuals and I did 001, 002, 003 up to 100, if I had to go 3 digits at a time that started with 0 or 100 exactly, it's going to take me forever going through this list trying to find those values. So the fewer the digits I can use, the faster I'm going to be able to get my sample selected. Okay? Now the other part of this then, okay, why do we even need these random number generators? Why do we need a table of random digits? Why do they go to such extents to create these random digits? Okay? Why do we need a calculator to do this for us? Why can't we just look at the list and just randomly pick, right? So what I'm going to do here is I'm going to scroll up a little ways. There's going to be a list of numbers that pop up on the screen. What I want you guys to do is as those numbers pop up, I want you to just pick one. So just first instinct, don't cheat, don't change. Look at the list, pick a number, stick with that number. I'm going to ask you about it here in a second, okay? I've got their number. Okay, first instinct, don't cheat here. How many people selected the number 1? Okay, how many selected the number 2? How many selected the number 3? And the number 4? Okay, so look at that distribution here. Now, if we were truly random, what would we more likely expect to see here? Yeah, there should be about the same amount of selection each time, right? Now, they've done this study like tons of times, okay? Lots of different groups of individuals. They've done this every single time. You guys fell right in line with what they found. When given the choice of these 4 numbers, 75% of people will select the number 3. 5% of people will select the number 1. And then if you're worried about the percentages, the 2 and the 4, those kind of change back and forth from group to group, but essentially about 20% of individuals select one or the other. Okay? Humans aren't random. We can't do it. Okay? Even the processes we try to use to create random digits aren't always foolproof. Okay? A lot of times it's more pseudo-random than actual random. Here's another thing I want you guys to do, just real quick. In your notes, just off in the margin somewhere, I just want you to come up. So using the digits 0 through 9. So any single digit you want to use, just write down a list of 10 random numbers. So one single digit at a time, 0 through 9, write a list of random numbers, 10 digits. Oh, I'm sorry. Yes. That's the slope formula. That's what you'll use here.
Okay.
Yeah. Just first instincts, just write your 10 numbers.
Like you can only use each digit once?
I just said write down 10 digits, random numbers. Okay? Now, the only thing I told you guys was just write down 10 random digits, right? 0 through 9, anything you want, just as random as possible. So we're not going to get too far into this one, but what you'll notice if you look at your list, lots of people tend to choose 2 and 7 more often than anything else. But the other thing I want you to think about is as you were writing that list, did anybody have the same number directly after itself? Like, did anyone put like a 2-2 or a 3-3? A couple people. How many of you, as you were making it, as soon as you selected a number, in your head said, I can't select that number again? Or I selected a low number this time, I need to select a high number next time. I got to be away from what I picked. Right? A lot of people do that. That's not random. If we're truly random, every time I go to pick a new digit, any number has an equal likely chance of being selected again. Okay? So we can't do random. Our brains just can't process it. We can't do it. Okay? We're designed, we're ingrained to follow patterns, to do things that are not as random. So that's why we need the aid of these like random tables or random number digit tables, or the calculator that does it for us as well. Okay? So let's take a look at what this looks like then. So in this example here, we have 28 hotels that we're going to try to select from. We're going to use our table of random digits. So starting at line 130, we're going to choose an SRS of 4 hotels. So the selections are already up there, but I want you guys to kind of go through this process to practice kind of what we're dealing with here. But what we're looking at is starting at line 130, so you locate that line on your table. So this is that line. You should see these exact digits on your table, correct? Okay. So as we go through this, we labeled our hotels. So notice when I labeled, 28 was my largest value, so I have 01, 02, 03. Now when you do the labeling, a lot of times I try to keep things consistent by telling you which way to go, like go by column, go alphabetically, okay, or go by row when you label. That's just to make sure like when you guys are checking the answer key, you can see that you got the same thing I did. You know you did the process right. So with me dictating that to you, it's not truly random. In a truly random scenario, you would pick where you start. You would get a random sample of your own, which would be completely different than mine probably. Okay? But for my grading purposes on quizzes and tests, for your guys' ability to just make sure you're doing the process right, I restrict some of that so you guys will get exactly the same thing I do. Okay? So as we're looking through this then, because we're doing 2 digits at a time, we're just going through the list and we're just keeping track of any values that fall within our list. So from 01 to 28 is what we're interested in. So as I start going through the list, 69 would be the first 2 digits. I ignore those because they're not part of my list. 05 would be, so I'm going to select that hotel. That's the one that we highlighted here, Beach Castle. My next 2 digits would be 16, so that's the next selection I would make, which would be that Radisson. 48, I ignore. 17, I select. And then I continue this process. Now notice, 87 is my next, I ignore. What happens when I come to 17 again? I had already picked that specific hotel, right? So one of the things that's important to note here is when I'm selecting my SRS, when I'm describing, because that's one of the things I'm going to ask you to do in the homework today, you need to describe the process. So when I describe this process, I'm labeling my hotels from 01 to 28. I have to say exactly how I'm going to label, what the digits are going to be, okay? And then if I'm doing it alphabetically, by column, whatever the case may be, I have to tell people exactly how I labeled things. And then as I'm going through and I'm talking about the actual selection process, I'm going to pick 2 digits at a time. I'm going to ignore anything that's not in my list. But the other thing that's extremely important is I will always ignore repeats for right now. Any repeat value that I get, I've already selected that individual for the sample. I cannot select them again. So in that description, when you're telling me how you're carrying this process out, that is something that must be in that description. I'm going to select 2 digits at a time or 3 digits at a time, whatever the case may be, and we're going to ignore repeats. We're going to ignore any value that's not inside our list. And then I'm going to continue that process until I've selected the number I'm looking for. So then 40 is out of the thing, 95, 17 gets ignored again, and I just keep going 2 digits at a time until I get to my last value, the C club. Okay. So we can kind of see that illustration down here as well. Now the way I want you to write your answers for these, every time I ask you to create a random sample, I want you to write the numbers you selected. So I want you to write the labels that were selected. So I want you to write out like the 0, 5, the 17, the 16, and the 20. So I want this, and then I want you to translate that to the actual individuals. So 0, 5 was Beach Castle. So I want you to write out, we chose Beach Castle, we chose Ramada, Radisson, and C Club. Now the reason I want you to do that, okay, in some instances when I don't tell you which way to label, you might label yours by column, I might label mine by row. So the individuals we select will be different, but the labels we choose will not. So you should have the same exact labels as I do. I know I put these in the wrong order. But as we're looking at this, this is what's going to tell you I did this right because I got the same digits as everybody else. Okay? And then whatever you got from there.
Why did you stop at 20?
Because I only wanted 4.
Okay.
Yep. So I glossed over that part. So we were choosing an SRS of 4 hotels. Once I get to my 4th hotel, I'm done selecting.
So when you write them, does it have to be in the order that you selected them, or do you want to be like?
I would like them in the order they selected them. I messed up when I was writing them down. So technically these should be switched. But yeah, so you write down the labels that were selected. Your list of labels should match mine. Okay? Even if the actual individuals themselves don't match mine because you labeled differently than me. So I labeled this way. If you had labeled across the rows, you're going to get a different set of 4 hotels. Okay? So just be aware of that as well. All right. Next thing. I want you guys to do a sample now. So you're going to choose an SRS from this class using line 110 for the table of random digits. So you're going to select which people in this class are going to get an A right here, right now. Okay? So I'm going to come around and give you guys a label. Remember your label and hope that it comes up on that table for you. 1, 2, 3. Now I'm telling 1, 2, 3. This is 0, 1, 0, 2, 0, 3, right? What am I? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Did I get you guys yet? 21, 22, 23, 24, 25. Okay, so we're going 0, 1 to 25 is our list of labels. You guys start at line 110. Select 5 individuals, so 2 digits at a time until you have 5 values between 0, 1, and 25. Skip repeats. If you get to the end of the row, so if you get to the end of line 110 and you haven't found 5 people yet, then you go straight to line 111 and you start again. And you continue that process until you get your values. Don't lose your place. you get done selecting, check with your group, see if you got the same numbers as they did.
And then you write down. Oh yeah, so you're just finding, and like be careful, like 3, 4.
All right, so let's take a look here. So if we're using line 110, okay, on the table of random digits here, when we select our 5 individuals from the class, what was the first number you came across? The first valid 2-digit number? 18. And then? Okay. Yep. All right, so those would be our 5. So we would write down the labels that we selected. Okay, that's the first part of the step. And then we would translate that into the actual individual. So who was number 18? Okay, so Nabila gets an A. Who was 20? So close, Chris. 6? Uh, 8? And 12. All right. So congratulations to you 5. Okay, the rest of you gonna have to keep working. So now, calculator process. Okay, so now we're gonna figure out who should just give up at this point, get an F. So we're gonna choose an SRS of 5 from your calculator. So fire up your calculators here. Now again, when you're using the calculator, typically you would just generate your random numbers. You would pick whatever value you want to start at and start generating. But to try to keep things consistent, to try to make sure you can kind of check that you're doing it correctly, things like that, I'm going to usually give you a number to start with. So when we seed our calculator is what we call it. We're basically telling our calculator where to start in its table of random digits. So it has one stored in its memory. So we're going to tell it, here's where you're going to start, and then generate random numbers from that point on. Okay? So when I store this value, when I seed my calculator, I'm going to type the number into my calculator. So just type in 9423. You're going to hit that store key. So STO with the little arrow. It's right above the on key on the bottom left. Then you're going to hit the math button. You're going to go over to your probability list. So it should say PROB or PRB, depending on the operating system you have. And then you're going to select the very first option, which is just RAND. So on your screen, this is what you should see right now. Everybody there? So 9423, store, go to math, go to PROB, choose that first option. So you should see this. Now go ahead and hit enter. And all it's going to do is it's going to give you the number back. So it's just confirming this is where I'm going to start. Okay, so this is where I'm going to start in my table of random digits. So now we want it to start generating those random numbers. So the next thing I'm going to do is after I've seeded my calculator, I'm going to go back into my math menu, over to that PROB again, and then it should be, is it like option 5, say like rand int? Does that look right? I can never remember if it's 4 or 5. So option 5 says rand int, and then has like a little parentheses there. Okay, so you're going to select that option. It's going to ask for a lower bound. Now in this case, our lower bound would be the 0, 1. It's going to ask for an upper bound, which is 25 in this case. Don't worry about the n value right now. That'll be something we do later with simulations. So for right now, just type in the lower bound, type in the upper bound, go ahead and hit paste. And so you should see this on your screen right now. It should have it set up, randint, 0, 1, comma 25, right? Now at this point, all I have to do to generate my random numbers is just keep hitting the enter button. So when I hit enter, just do it once for right now. So hit enter the first time. What number comes up first? 11. Okay, everybody should be getting the same if we all typed everything in the same. So it should be 11. Then we hit enter again. 4. Now it's going to just say 4. It's not going to put the 0, 4 on there. Okay, so we translate that. 0, 4. Then what's next? 15. Then 14. And 18. Short-lived day, Nabila. Sorry. All right, so 11. Who was 11? Molly. Better luck next year. Number 4, Mia. Number 15, Bryant. 14, Christian. And 18 was Nabila. She lost her A right there. Okay. So that's how we do the random selection. Okay, so whether you're using the table, whether you're using the calculator, those are going to be the processes. So it's going to be important that as you guys go through the homework, really focus on the description of the process. How exactly am I labeling my individuals? How exactly am I selecting the numbers? If I'm using the table, how many digits am I taking at a time? What am I ignoring? I'm ignoring things outside my list. I'm ignoring repeats. And I'm going to continue until I have the number of values I need, right? And then when we give our answers, give the numbers that we selected, the labels, and then translate those into the actual individual selected. Everybody with me on that? All right. Last thing, sampling variability. So this is a really important topic here. So it's important to understand that when we take these random samples, and this is the whole point of random sampling. When we take these random samples, the whole idea is for us to get a representative sample from our population. Like when I collect my sample and I measure whatever variable I'm looking at, I want that value that I find to be close to the true population parameter. So employing randomization is my best way to ensure or give myself the best chance at getting that representative sample. But what we have to understand is that when we draw samples at random, they're going to be different from one another. So what's going to happen, like yesterday we talked about if I want the average height of students at this school. We said we're not going to go find all 1,900 students, measure their heights, calculate the true average, right? We're going to take samples. Now, if we were to perform that process, so we're going to select 40 students from the school. So we would get a list of students from the admin. We would label those students from 0001 to 1900, or whatever the number is that we actually have. Okay, and then we'd start the random selection process. So if I was going to do an SRS, that's what I would be doing. So if I selected a sample of 40 individuals, I'm going to pick a specific spot for me to start on the table or start in my calculator, but I'm going to generate my sample of 40 individuals. And then if I told each of you to select your own random sample. So Jake's going to pick his own starting point, either in the calculator or the table. He's going to select 40 individuals. He's going to go get those. Marin's going to go get her sample of 40. Christian's going to go get his sample of 40, and so on. Now, since we're all picking different spots probably, that means we're all going to be generating different random samples. which means when we calculate those average heights, is my x bar, is my statistic going to be the same as Marin's? Probably not. Okay. Is mine going to be the same as Brody's? No, he's going to have a different value. Okay. Every time we sample, we're going to get a different statistic to estimate that parameter. That's sampling variability. So just understanding that if I take random samples from the same population, by the very nature of that random selection, I'm going to get different estimates every time. Because as we discussed earlier, that SRS, I'm giving every possible sample the equal chance to be selected. So every time I do a new random sample, I'm probably going to get a new estimate for that parameter value. This idea of sampling variability is going to be part of the entire idea for next semester. When I continue to sample over and over and over and over again, I get these different estimates every single time. But as we do that, those estimates are going to start to center in on what that true population value is supposed to be. That's why this randomness is so important. You will sometimes, not very often anymore, but you will sometimes see it referred to as sampling error. It's not an error though. It's not a mistake. We expect that to happen. One sample to the next should be different. Should give us different estimates of that true parameter value. So just being aware that those random samples are truly random. You're going to get different results every time. Now, we're going to restrict some of that on the homework. Okay? In theory, if you guys were to do the homework where I put no restrictions on it, you should all be giving me a different answer probably. Because you should all be starting in a different spot, using a different process. You should be getting different numbers. Okay? But to make sure we're doing the process correctly, that's why I'm going to say use this line, seed the calculator to this, so you can verify that you're getting the same numbers I do. Right? And so you can check kind of how that works. And then on quizzes and tests, obviously, it makes it easier for me to grade to make sure that you guys did it correctly. Okay? So, with that, these are the problems I want you to try out for today.